Greetings. I showed you in the power distribution video that I would be using a DC-DC converter to send 48 volts up the tower to the box, to the remote box where all the electronics are. And this is the one. This unit is a DC-DC converter, 150 watt and maximum dissipation. It's C&D Technologies. It's model VKA 150 MS12. So it's a 12 volt DC-DC converter. It can take between 33 volts and 75 volts input, up to 7.5 amps, depending on the input voltage, of course. The lower the input voltage, the higher the maximum current will be. And on the output, it can deliver 12 volts at 12.5 amps. And it can be trimmed down or trimmed up a little bit. The downward trimming can bring this unit down to 10 volts. I will actually adjust it to 10.2 volts to compensate for cable losses. So it can be trimmed down using the trim pin, and you just put a resistor. In my case, it's going to be 4.7 kilo ohm resistor attached to the minus V out to the ground, and it will bring down the voltage. So 10.2 volts out. I will be feeding around 50 volts from the shack. There will be some losses. It's a 20 gauge wire I will be using. So maybe it will end up being 45 volts up on the tower, 46 volts. I don't know. I haven't computed the losses yet. But I expect a maximum current of 2 amps at 50 volts. So this thing needs a heatsink. So I will bolt it down to the aluminum plate that's going to sit at the bottom of the enclosure to dissipate the heat using 4 bolts. And as far as interfacing these pins, this obviously is designed to sit on a PCB and be soldered down on a PCB. It's a recovered unit, by the way. This is not new, it's recovered. So in order to use this thing the best way possible, I've designed a PCB that just connects to the unit from the top like this. This PCB will give me full access using screws and terminals to the input pins, the output pins here. It will also allow me to trim down using an onboard resistor, and it has capacitive filtering and a common mode choke on the output. Here it is. It'll get soldered down, and this is surplus material which I've recovered. And this unit, the number will not tell you anything. It was originally for Northern Telecom, Nortel. It is a 20 ampere version of the Pulse P0502 series of common mode choke. And you can see here the 2 coils underneath. And you just solder this thing down with some capacitive filtering on the input and output. It does help. I've checked, I've tried the unit. It does help to reduce the amount of hash noise, harmonics of the switching frequency, because yes, of course, this is a DC-DC converter, but it operates in switching mode at around 400 kilohertz if I'm not mistaken. And the whole assembly, once put together, all components soldered, including the DC-DC converter, and bolted down to the aluminum plate, this is what it's going to look like. I'll be using M3 screws to attach the cabling for the input and output using regular terminals. And I've used some thermal pad. I have some extra thermal pads that I put between the aluminum plate and the DC-DC converter itself to send the heat down to the plate. I've used, once again, M3 screws through the PCB to attach the DC-DC converter to the aluminum plate. So what's left to do is to wire up the 48 volts and the 12 volts, and that's going to be easy to accomplish. So there we go. 10 volts at least 12-13 amps available up in the box. Now again, heat management will be a challenge because this will add up to the heat generated by the OCXO and mainly by the power amplifier when transmitting. Anyway, one thing at a time. So I'll get back to wiring up the whole thing, and that's all for now. See you soon. 7-3.